All right, so today we are going to be solving polynomial equations. Last week we added, subtracted, and multiplied them, and today we will be solving them. So go ahead, take out your spiral notebooks. You can pause this video at any time that you need so that you can get stuff written down into your notes. We're going to go ahead and get started. So first off, this is the zero product property. And basically all it does is it gives us a reason for why we are allowed to solve these polynomial equations the way that we are going to. There's also a little note down here that the solutions of a polynomial equation are also called roots. They have other names as well. You will see them as zeros, and they are also x-intercepts. All three of these names, I guess four if you count solutions, will be used interchangeably to describe the solutions of these types of equations. So you just have to familiarize yourself with this terminology. So our zero product property states that if we have two numbers that are multiplied and they equal 0, we can actually separate those two numbers and set them equal to 0 on their own. And that is what we are going to use to solve these equations. So for our first example, we have these two equations here. Before we get started, though, I want you to write down a note to yourself real quick. Before we start solving any type of polynomial equation, before we start solving any type of polynomial equation, we have to make sure that that equation is set equal to 0 first. This is something that is going to come up again and again and again. Notice this equation is equal to 0. This equation is equal to 0. So we don't really have to worry about it yet in this situation, but it will become an issue in the future if they're not equal to 0. So going back to our zero product property, it stated that if we have something multiplied that equals 0, we can set each of those separate pieces equal to 0. So that's what I'm going to do here. So this is going to become 2x equals 0, and x minus 4 equals 0. All right, I'm going to try to figure out why this is going in and out. There we go. Hopefully it stops now. Okay. So now that these are equal to 0, you can see that these are basic equations that we've solved time and time again. So here we'll divide by 2. And we'll get that x equals 0. Here I'll add 4. And we'll get that x equals 4. So our solutions to this polynomial equation are 0 and 4. Over here, we're going to do the same thing. So we have this times this equals 0. So if we set this equal to 0 and this equal to 0 separately, we can solve. So x minus 3 equals 0. X minus 9 equals 0. This is very similar to the process that we used when we were solving absolute value functions as well. So here I'll add 3 to both sides, and x will be 3. Here I'll add 9 to both sides, and x will be 9. So you go ahead, pause the video, take a minute, do these two yourself. So check your answers. Let's see what we've got here. We'll set 3t equal to 0 and t plus 2 equal to 0. Here I'll divide by 3 and t will be 0. Here I'll subtract 2 and t will be negative 2. For this one, I'll have z minus 4 equals 0 and z minus 6 equals 0. I'll add 4 here, and z will be 4. I'll add 6 here, and z will be 6. So, hopefully you got those right. Let's move on to our next example. Okie doke, so for this top one, this one looks very similar to the ones that we've already done. So we're just going to apply our process again, setting each part equal to 0 and solving. So I'll have 2x plus 7 equals 0, and 2x minus 7 equals 0. And then we just solve each one separately. So I'll subtract 7 and divide by 2 for this one, and x will be negative 7 halves. For this one, I'll add 7 and divide by 2, so x will be positive 7 halves. And we've seen this type of situation before where you have a positive and a negative solution. And just so that you, a little bit of a reminder so that you remember, you may see it written this way in your textbook. X is equal to positive and negative 7 halves. I don't care which way you choose to write your answer, if you want to write it separately or combine them, totally up to you. For this one, it's equal to 0, so we're good. How do we solve? Well, we have a situation here that's a little different. We have this square. In order to solve, we're going to need to get rid of that square. We are not going to apply it. If we actually square this, that's one of those special products from 7.3, and we would have a squared minus 2ab plus b squared, and all we did at that point was unfactor it, and then we're stuck. Then we're going to have to go backwards and factor it again. So we don't want to multiply anything. How do you get rid of an exponent square? What's the opposite of an exponent? A root. So to get rid of a square, we are going to square root. The square and the square root get canceled out over here, and I'm left with x minus 1. Square root of 0 is just 0. And now I have x minus 1 by itself. There's nothing else going on, so it's just going to be x minus 1 equals 0, which I add 1, and x will be 1. And for part C, the only thing that's different about this one is now I have 3 pieces. So what do you think I'm going to do? I'm just going to set it equal to 0 3 times. So x plus 1 equals 0, x minus 3 equals 0, x minus 2 equals 0, and solve each one. So x will be negative 1, 3, and 2. So it doesn't matter how many factors you have. However many there are, that's how many times you're going to set them equal to 0 to solve. So you try these bottom two. Go ahead, pause the video, and see what you come up with. So for number 3, we see we have a square we have to get rid of. We'll get rid of it with a square root. And this becomes b plus 7 equals 0. Subtract 7, and b will be negative 7. Here I have 3 separate factors, so I'm just going to set each one equal to 0 and solve. And my 3 solutions will be d is 2, negative 6, and negative 8. So I hope you got that. Okay, now we are going to factor. We're going to factor out the greatest common monomial factor. Really, if you think about it as greatest common factor, you're good. It will end up being a monomial, but don't get so caught up with the wording that you get confused. We're just going to find the greatest common factor here. This is not as complicated or as difficult as the directions are implying. To find a greatest common factor, first start with your numbers. I have 4 and 24. What is the highest number that both 4 and 24 can be divided by? That number would be 4. And then let's look at our variables. I have x to the 4th and x cubed. The exponents almost tell us how many there are. X to the 4th, we have 4 x's. X times x times x times x. X to the 3rd, x cubed, we have 3 x's. X times x times x. So when you're looking at your variables, you want to think, how many can I take out? If I've got 4 here and 3 here, how many can I take out of each one? What's the highest number I can take out of each one? It would be 3. I can take 3 x's out of 4 x's, and I can take all 3 x's out of the 3 x's here. So x cubed is going to be the greatest common factor for my variables. Now we just have to think of what are we left with. If I take away 4 from 4, if I divide out 4 and 4, I'm just left with 1. If I take 3 x's out of 4 x's, I'm just left with 1x. So it's 1x, which is just x. If I divide 24 by 4, I'm left with 6. And if I take all 3 x's away from these 3 x's, I don't have any x's, so all I'm left with is 6. So this is going to be your factored out version of this polynomial. And you can always double check it too. If you multiply it back in, 4x cubed times x, well, I add the exponents, this is going to be 4x to the 4th. 4x cubed times 6 will give me 24x cubed, and what do you know? Those match. So go ahead, pause the video, and try number 5 on your own. Factoring out the greatest common factor from 8y squared minus 24y. All right, so 8 and 24, what's the highest number they have in common? 8. Y squared and y to the first, what's the highest number of y's they have in common? 1y. If I take 8 of 8 and one of the y's away, I'm only left with 1y. Minus 24 and 8 is 3. If I had 1y and I took 1y away, there's no y's left, so I'll be left with this. 8y times y minus 3. Okay. Now we're going to apply the factoring and the solving all together. I'd like you to write yourself a little step-by-step instructions on how to solve these types of equations. First, the first step when you solve these is to make sure that it's equal to 0. If it's not equal to 0, you're going to have to do some addition or subtraction or something, moving around to get it equal to 0. Step 2 is to factor it. If it's not already factored, you will need to factor it using the process that we did on the last 2 problems. And then step 3 is the last step, and that's just to solve it. Remember, when we solve it, we set each factored part equal to 0 and solve on down. So let's take a look here. 2x squared plus 8x equals 0. Step 1, make it equal to 0. It already is. We're good. Step 2, factor. It is not factored, so we will have to factor. So look for our greatest common factor. 2 and 8, the greatest number they have in common is 2. X squared and x, dang it, I did that again. I did that earlier. They have 2 in common. X squared and x, what's the highest number of x's? I can take away from both, one of them. If I take 2 away and 1x away, I'm just left with 1x. If I divide out 2 and take away one of the x's, I'm just left with 4. So this will be 2x times x plus 4. Step 2 is done. Now step 3, I have to solve. So I'm going to set each factored piece equal to 0 and solve. So my solutions here are 0 and -4. Alrighty, let's move on to B. 6n squared equals 15n. Step 1, make it equal to 0. This is not equal to 0. Technically, there are 2 ways I could make it equal to 0, but one way is better than the other. Write yourself a little note. The lead coefficient should be positive. Remember when we were doing standard form of polynomials and it went from like the biggest exponent to the smallest, and the number attached to the biggest one was our lead coefficient, that first number? If you can make it positive, it will make your life easier to always have our lead coefficient be positive. So in this case, our lead coefficient is 6 because n squared is bigger than n. So I want to keep this 6 positive, which means to make it equal to 0, it will be a better idea to subtract 15n, not subtracting 6n squared. So I've made it equal to 0. Let's factor. 6 and 15, a number that they both can be divided by, is 3. N squared and n, highest number of n's I can divide out is just one of them. 6 divided by 3 is 2. N squared divided by n leaves 1n minus. 15 divided by 3 is 5. N divided by n over n cancels out. So I just have 5 there. And now it's factored and I can separate them and set each piece equal to 0. And then I'll solve. So I'll get n is 0 and n is 5/2 for this right here. You pause the video and try these 2 on your own. All right, so 6, step 1, make it equal to 0. Check. Step 2, factor. What do these have in common? 3 and 9, I can divide 3 out. S squared and s, I can divide out one of the s's. 3 divided by 3 and s squared divided by s leaves 1s behind. Minus 9 divided by 3 is 3 and s divided by s, no s's left. Separate them and solve. So in this case, we're going to have 0 and 3 as our solutions. For number 7, step 1, make it equal to 0. We got to do that. But our lead coefficient, in this case 4, should be positive. So to make it 0, I'm going to subtract 2x from both sides to get this. Step 2 is to factor. 4 and 2, what's the highest number that can be divided? 2. X squared and x, what's the highest x's that can be divided? 1. 4 divided by 2 is 2. X squared divided by x leaves 1x minus. 2 divided by 2 is 1. X divided by x is 1. All that's left here is 1. It is not 0. Remember, we're not subtracting, we're dividing. When you factor, you are dividing. 2x divided by 2x, anything divided by itself is 1. 3 divided by 3 is 1. 10 divided by 10 is 1. X divided by x is 1. So you have to leave this minus 1 here. Set them equal to 0 and solve. So our solutions here are 0 and 1/2. I know I'm going fast to the solving part, but these equations are super basic, super easy, stuff you did all last year and the beginning of this year. You should be totally experts at that right by now. Alrighty? All right, last one is a story problem. As usual, please pause, take a second, write down the problem. So we have this yellow fireplace arch here, and the arch can be modeled by this equation. This x-axis represents the floor. So this arch is like the opening of a fireplace. And we want to find the width of the arch at floor level. So essentially, the width on the x-axis. So I've got this point and this point, and I want to know how wide it is in between it. So I'm looking for this length right here. Well, looking at this point and this point, those are on the x-axis. Going back to the very beginning of our notes, solutions to polynomial equations are known as x-intercepts. Where the graph crosses the x-axis is where the x-intercepts are. So if I can find these two x-intercepts, then I will be able to figure out what the distance between them is, therefore figuring out this width of the arch. So I want to find x-intercepts. X-intercepts are solutions. I have the equation here, and I want to find the x-intercepts. Well, x-intercepts are solutions, so essentially all I'm doing is solving this. Going back to our last example, what's our process for solving? 3 steps right there. First, I make it equal to 0. Right now, it's equal to y. Y is a variable. I can make that variable whatever I want it to be. So I'm going to make it 0. Also, if your y values are 0, that means you are on the x-axis, which is what I want in the first place, because I want my x-intercepts. Now you may be starting to see why these words, solutions, x-intercepts, zeros, are interchangeable. Step 2 is factor. That's already done for us. Good news there. Step 3 is solve. So I want to set my pieces equal to 0. Well, if I have negative 1/9 equals 0, does that make any sense? No, because negative 1/9 isn't 0, so it can't equal 0. Right? Like, what if we had the number 2 here? Does 2 equal 0? No. The reason that that doesn't work is because there's no variable here. It's just a number. Because it's just a number, I can't solve anything. It's just a constant. It just is -1/9. So it doesn't have anything to do with when I'm solving it. So essentially, I hate saying this, but you can kind of ignore it. We'll set our other pieces equal to 0 because these pieces do have variables in them. So there is something that I can solve for. So that's exactly what I'm going to do. So I have x is -18 and x is +18. So those are my solutions, which are x-intercepts. So over here, my x-intercept's -18. Over here, my x-intercept's +18. So you may think, okay, cool, I'm done. Answer is 18. No. We want to know the width. We want to know the distance between these points. How many spaces are there between -18 and +18? 36. So the width of the fireplace base is 36 inches. And that is going to be our final answer. So I really love this question because not only does it have you solving a polynomial equation, it also has a relationship between the polynomial and a graph. And after you solve it, you then have to apply what you know to actually answer what the question was asking in the first place. Okay? So go ahead, you can get started on the homework for the remainder of the hour. One quick reminder, it is February 2023. I passed back 6.4 retake forms last week. If you want to do a 6.4 retake, those forms are due tomorrow. Reminder, this is only for February 2023, so if I ever use this video in the future, you can ignore this. But for right now, your retake forms are due tomorrow. I will not accept any more 6.4 retake forms after tomorrow. Okay, have a good one.